All right, good morning, everybody. Thanks for waking up early to come nerd out about APIs today in our tutorial this misty morning. My name is Dave Anderson. On Twitter, I'm Dave Anderson without the vowels. Our tutorial today is called Building Evolutionary API in Python with GraphQL. Before we get started, a little bit about me. I'm a lead developer consultant at Stride Consulting, based out of Manhattan, New York. I'm also co-host of the Definitive Developers podcast, The Rabbit Hole, where we talk about human vectors of software engineering, as well as fun new tech like GraphQL. That's episode number 52. Have a listen, like, and subscribe, and all that. I've worked with GraphQL for almost 2 years now on several projects, helping various companies rebuild their stack with similar technology to what we'll use today. Python with Django, Graphene, JavaScript, Apollo, and React. Stride's hiring for software development consultants to co-locate with clients in New York if you're interested, so feel free to chat me up. I also wanted to talk a little bit about you guys. Since this is a conference, we're here to network. I really appreciated you guys taking the time to respond to my survey. It was great hearing about your interests and backgrounds. People were enthusiastic about all kinds of things, from medieval times to Westerns and APIs, of course. People are coming from such distant locales as Boston and Taiwan. Software engineers working in all kinds of fields like finance, construction, materials, and all kinds of different angles of the technical spectrum. Lots of experts in Git, but some newcomers, both newcomers and experts in Django and unit test. So yeah, all kinds of people today in this tutorial. So before we get started, I just want to take a couple of minutes, maybe 2 minutes, to meet your neighbor. One of my favorite things about coming to conferences is getting to meet people, so given the crowded room, might be a little more difficult for me to meet everyone, but we can meet a couple of people, and it might be good to find out what we're looking to get out of the tutorial, what they might be unfamiliar with, being Django, Git, testing, or some other technology, and if there's a way we can help to meet each other's goal. We're going to be collaborating together in exercises, so hopefully this will be helpful to know where everyone else is out, and we can move through the exercises quickly, working together. So yeah, just take like maybe 2 minutes. All right. So, I know we're having fun chatting up. We'll get to collaborate a little bit more later. So, yeah, let's get back to it. Why are we here? We're here to talk about focus. GraphQL. what is GraphQL? That's the first thing, right? Some of you guys may be familiar with it. GraphQL is a query language for your API, basically meaning much like SQL. You can specify the fields that you want to get out of the API and get exactly what you've asked for in response. So GraphQL is a specification. It's implemented in many languages and frameworks. The ones that we care about, since we're at PyCon, is Python and Graphene, particularly. GraphQL provides a system of constraints that help us drive a constantly evolving API. So one of the things that we like to focus on today is how these constraints that Graphene and GraphQL put us in help us safely evolve our API over time. So our focus today is going to be on answering questions like, what is GraphQL and what are its benefits? How do I get started with GraphQL and Python? What does it mean for an API to be relay compliant? What kinds of changes are safe to make my API as clients begin consuming it? How can I ensure my GraphQL API performs well? How should I design mutation responses for my GraphQL API to serve client needs? And why GraphQL? So this is a lot of steps, so let's keep moving on. So if you go to graphql.org, you'll see 6 bullet points that kind of describes talking points for why GraphQL is a helpful framework. Let's dig into those one by one. So the first bullet point is ask for what you need and get exactly that. So like I mentioned before, it's a query language for your API. You can avoid data overfetching by clients. You don't have to worry about sending too much data over the wire that may be expensive to commute because a client may not actually need it. It's easy for clients to express precise field-by-field data requirements, which are lazily evaluated on the server. So if something's expensive, like I mentioned before, you don't have to worry about that getting sent down to the client if they don't need it. This also encourages concentration of business logic and the domain model and the API in the back end. So that means that our clients can be lean and focused on presentation of data. And if we need to pivot or make a new platform in the future, like a mobile platform or a public API platform, it's a bit easier because we're not as committed to it. An example of that, recently, Facebook had a complete rewrite of their platform using GraphQL. And the client that they're using is very lean and mainly focused on presentation of data. So that's how they were able to do something like that. The next bullet point, one request for all your data needs. This basically means that we can avoid n+1 for resources and clients. An example of an n+1 resource, if you have like a really structured REST endpoints, you might have like an endpoint for author, and you want to get like the publisher's address. And so you would need to request the author, and then the stories from the author, then the publisher, and then the address. So that helps us to have more structured requests for data that can be like all co-located together for one page load or specific components and user interactions. Basically a more declarative way to describe what data we're going to be using in our API and in the components in the front end. The single endpoint also increases discoverability and avoids versioning more endpoints than a squid has arms, which is nice. The next selling point is that we can describe what's possible with a type system. Everything in GraphQL is statically typed. The specification requires a schema with every field defined and typed. We can introspect our GraphQL schema in real time, provide documentation and powerful tooling, and it's also a contract with our clients. Clients themselves actually request the data using static queries against a static schema, ensuring that we have a safe contract. And that's something that we can use to validate for breaking changes in our API, which can be very useful. We can also evolve our API without versions. So GraphQL Schema provides a safe guide for evolving over time. Confidence in making changes encourages building only what you need now, and embrace you ain't gonna need it, or YAGNI, and evolve as our needs become more clear over time. We also have first-class tools for deprecation and control changes to APIs in case we can't evolve safely. The next bullet point is about moving faster with powerful developer tools. So static schema typing and runtime introspection allows tooling to help you move faster. An example of this is like powerful IDE-like editors for rapid prototyping of queries and clients, like GraphiQL, a tool that we'll be using today. And also, you can have a robust client in your front-end web application to manage concerns like caching and asynchronous actions, which let you focus on code that matters. So an example of that is Apollo, which we'll be using today. You can bring your own data and code. So there's broad support across languages, starting with JavaScript. And over time, more clients are available, including Python. The Python community is growing also, which is pretty exciting. We've had Graphene, which is a very established and fully featured client or a server that we can use. But there are also newcomers like Ariadne and Strawberry. And more people are getting involved in the community, so it's kind of an exciting time to be involved. Lastly, GraphQL can be a unifying API for any kind of data source. So basically that means we can leverage that as glue for other data sources and APIs. Because it has that static type, it's very easy to provide a backend for microservices or other data sources. It can also be a backend for frontend for almost anything. So GraphQL can be a gateway that allows us to cater to the needs of mobile, web, and outside clients. So let's talk some logistics before we get going. I think some of this may be a repeat if you've reviewed the references and stuff, but I'll try to get through it for anyone who may have missed those. So the general schedule for the workshop, I'm going to be trying to follow a Pomodoro, 25 minutes on, 5 minutes off, where we can like get some water or ask some questions. I have a handy dandy clock running right now, so we have about 12 more minutes on this Pom. We'll also be doing lectures and exercises, kind of going through GraphQL and Graphene basics, relay compliance, schema evolution, performance of APIs, and mutations and client-side concerns. General principles with design this tutorial, like I would definitely encourage you guys to pair on exercises to share your expertise and help each other move through the exercises, and also have a little bit more fun, hopefully. The tutorial code kind of tried to follow these general coding practices where the API code is very simple. Most of the logic is in the models and service layer. We drive solutions for the exercises in all these with tests that are already prepared for you, so you'll know when the solution's right. And we model our API and core domain in the code. Cool. So each chapter has at least one branch in the Git repo. We'll start with the branch chapter 1. And some chapters have multiple branches. We'll indicate which branch should be checked out for the exercise. The project setup is in the README. There's a pretty self-explanatory invoke script that will help you get set up quickly, I hope. There are some compatibility issues with Windows, so running the check and start commands may not work properly on Windows, but you can just use the pipenv script that's listed in the README instead of that. Also in the repo is a references file that some of you may have seen already. This kind of has like some basic commands that you will need to do. Pretty much for our purposes, we just need to check out chapters and make our working tree clean. So either save the work in progress or reset or stash the work that you have. For our Python environment, anything above 3.6 should work fine, but I'd recommend the latest Python. We'll be using pipenv for the virtual environment, and also using pipenv scripts functionality to like centralize all of the useful commands that we will be using. Like I mentioned before, using invoke as a task runner, and pipm script for our build scripts. So there are some nice tasks that you can use while you're going through the tutorial. I'll call them out in the exercise explanation as needed. But if you want to poke at it a little bit, you can list the tasks using invoke-l, and each of the tasks has some corresponding pipm script that it's deferring to. So for this code base, we're using unit tests for testing. They're pre-written for each exercise. Basically, if you run the tests, you'll know if you're implemented properly or not. We're using pylint and mypy for linting and type annotations. Type annotations hopefully are useful for folks here, even if you haven't seen them before. Basically, we have the argument here, which is root, and then the type that that argument is. So in this case, our root is a story model from our Django ORM. And this info is from graphene. It's the resolve info. And display is just a string. We also have the return type here, which is a string. So hopefully that demystifies some of the weird arguments that you might see flying around in a GraphQL resolver, which we'll get to a little bit later. We're also using Django. You'll have to write some Django during some of the exercises, but the key commands are kind of here and listed in the references. So, hopefully your neighbor is familiar with Django if you're not. So finally, getting to GraphQL and Python. Graphene is our focus today. That's a code-first library, meaning that we will write Python code instead of defining the schema through the GraphQL schema definition language, which a library like Ariadne, which is another newer GraphQL library in Python, uses. So in Ariadne, you would write a special GraphQL syntax for defining the schema, and then write Python to bind that schema to your Python models. Ariadne also supports async I/O. There are other newcomers like Strawberry, which is code first as well as Graphene, async I/O, and uses data classes under the hood. So yeah, it's an exciting time to be involved with GraphQL and Python. Cool. So let's get into the actual material. So to start off with, let's just have a simple API, just one resource listing stories. So how would we get a list of the titles and authors for those stories with REST and GraphQL? So with REST, to get the stories and authors, story titles and authors, we don't really have a schema. It may be documented in something like Swagger. We may have some other generated documentation or a README. We may ask somebody which endpoint to use on their team. But eventually we'll find our endpoint. So we'll get our API v1 stories, and we'll pass an argument for how we want the name to display. And then we'll get a response, which may be a little bit more data than we really need right now. With GraphQL, we have a schema that's defined. With Graphene, we don't write this schema, but we can generate it from the code that we've written. We'll get into a little bit about what these different parts of the schema are. It's useful to know generally what the GraphQL STL syntax is. So that way, if you are interested in using another library or JavaScript library, you can read the documentation, understand it. When we have that schema set up, we'll send a query, and we'll get back some data in the same shape that we asked for. So let's pick apart each of those pieces now. The first piece is the schema. So as I mentioned before, this over here is our schema definition language that describes our API, the fields that are available. We have a root query, which is basically the entry point to our API. We only have one field on the entry point, which is stories, and it is of the type story type, which we define over here. So that's a custom object type that we've defined. And that object type has fields using scalars, like strings and ints and floats. We can indicate required fields with a bang, an exclamation point there. We also have arguments that we can define on any field at all, which is incredibly useful for describing the data requirements for our front end. So in this case, we have a name field, and we pass an enum to indicate the display format, which in this case is first or last. We also have array fields. So just like in Python, those are indicated with square brackets. And we can also define enums, lists of related values that we can use in the API. So next, we are writing a query against that schema. So here we have the optional query keyword. In most cases, that's understood, but it's useful to include that sometimes. We also have an optional operation name, so we can call our query anything we want. It's just a convenient thing for our clients to use. So we could call this query pants if we wanted to, and it would be fine. This is our field on the root query, so we have stories on the root query. That's our first field that we're fetching. We have a selection set of fields on the object, the fields in the selection set, and the arguments and values for those arguments. So when we send that to the server, we're going to get some JSON results back. And those JSON results are going to be exactly in the shape of what we asked for. So only the fields that we've asked for in the selection set are evaluated. So if we need to change data, we can write a mutation. So in REST, we might write a put or delete or patch. In GraphQL, it's only a mutation. So in this case, we still define a schema. We send the mutation, which looks very similar to the query, except we have a mutation keyword instead of a query keyword. We pass some input variables in our arguments. We do some operations, so we create the story, and we get back the data using this story type. So this is exactly the same story type that we defined earlier for our queries, so it leads to some good code reuse. We don't need to re-implement the wheel, and the user has a lot of flexibility as to what data they fetch from that. Like if we had other connected types on that story type, we could keep fetching all day. Cool. Yeah. Oh, actually, we have a mic for questions, so. I was just going to ask about questions, so.
In both of the two slides here, you mentioned create your schema. That's on the server side that the developer or the API developer would do, correct? Or
That's right. The schema will be defined on the schema or the server side.
Okay, and the other queries that you're doing are pulled from the schema.
The queries are sent by the client to the server.
Got it.
And they'll match up with the schema that we provided there. Cool. Any other questions? I think we got one more minute. Yes, the slides will be available. So the question was, are the slides available?
Not right now, though.
I can make, do you want to follow along or something?
Yeah, it's kind of small way back here. We can turn off the front lights, that might help. Really watch.
Okay, cool. That's good feedback. Well, we have our first palm break coming up, and I'm going to try to make that available. Sure. Cool. So yeah, let's just take 5 minutes. I'm just going to grab some water and make that available for you guys. Okay, so I made those available now. So if you look in the README in the repository, you should be able to click the link and follow to the slides. Just let me know if you're able to access it. Yep.
saying locking this.
It will eventually time out. It's the internet connection. The internet connection. And use your phone, it helps. No, seriously.
I abandoned Windows and security shelled into a VM on Linux on my phone.
I know Windows is wrong, I got it.
That was part of the reason why I put that tutorial out. I was like, how many people are using Windows?
No, he's not on Linux.
Are you? Okay.
I think it's probably the Wi-Fi.
The download speed is 0.3 megabits per second.
There's too many people in here, I guess.
Yeah, it's not even the main day. That's not a good sign for
Any other questions or setup problems?
I'm getting an error on the Windows setup where it says cannot find the version that matches REST.
Okay. It seems like that's a similar thing with the dependencies.
Well, it's not that it's hanging, it's just that it's not finding.
And you're on Mac. Got a minute. Come back. Okay. All right. So let's keep moving forward. So hopefully most of you guys have everything set up properly. I know there are a couple of issues. One of the tools that we were using today is called GraphiQL. GraphiQL is a very helpful tool for exploring your API. basically, it's like an IDE for prototyping queries. So on the left-hand side here, we have a query editor where we can write queries, and it has like autocomplete and all kinds of helpful features. On the right, we have the query results, which is the data that comes back from our server. We can also pass in some variables into our queries when we're sending it to the server, which we'll get into a little bit later in this talk, but for now, don't worry about it too much. So GraphiQL provides some powerful features for rapidly prototyping queries for your API. So we can run multiple operations. So we have multiple queries here. Each have their own name, their own operation name, and we can pick them to run. We can prettify our query and make it look nice or check that it's valid against that schema. We can also like check the history of queries that we've run. And probably most excitingly, you can actually browse the documentation. So you can search the documentation, see what the description of all the fields are, and really discover what kinds of things are available in your API. So some power user tips. You can hit Control and Space to do an auto-completion hint. In the query editor window, you'll get that automatically when you start typing, but it can be nice to hit that before you start typing to know what you can even type to begin with. You can also hit Control and Enter to run under the cursor. So if there's multiple queries in your window, Control and Enter will run that query that your cursor's on right then. So let's do an exercise. So we'll try to pair up. Ensure you're on the chapter 1 branch. Open up this file, API queries.graphql, for some sample queries and instructions on how to get started. And run some queries in GraphiQL. Just copy over those queries into GraphiQL, spin up your server, and try to add some new fields, change some arguments, explore the documentation. Just get comfortable with using GraphiQL.
Dumb question.
Yep.
I missed the part where we figured out how to run GraphiQL.
Sure. So if you start your server, you can go to localhost 8000/GraphQL. And if you open this API/queries.graphql, there's some more detailed instructions in there too. So let me actually pull that up. Oops. Sure. So the question was, what are we querying when we run this? So there's actually a database locally. There's a SQLite database. There's some Django models, and next step we'll like dig into how that's implemented. Take another like 4 minutes or so just to get set up and comfortable with that. Happy to answer any questions people have too while we're working through that.
Can we try the mutations now, or is that something we can do later on?
Yeah, you can try that actually. So there is a mutations.graphql file. So if you're comfortable with the queries, feel free to open up that mutations file and take a look at that as well. So let's see. So that's a similar path to the queries file. And yeah, you can just paste it in there. And also, if you're curious to like poke at something that's a little bit more meaty than this, right now you can check out this URL here, developer.github.com, v4 Explorer. So if you sign in with GitHub, you can actually query anything about yourself on GitHub. Like I have a sample query here. So here's some comments that I had on GitHub. And this API, the GitHub API, is actually like one of the most robust and like kind of gold standard APIs for GraphQL that's out there. Since we have a couple minutes. Since we have a couple minutes, I'll just show you, like, this is the kind of craziness that you can have with a GraphQL schema. So this is GitHub schema from their, like, root query. So they have, like, organization, repository, repository owner, resource. Those are, like, the root things they make available. And from that, we can go take a look at repository, see what fields are there, what kind of issues are on that repository, what kind of users edited that. So all kinds of stuff. And that's kind of, this tool is driven by that GraphQL schema that I was talking about. Okay, cool. All right, why don't we move ahead? Any other quick questions before we move on? In the back? Yeah, let's do that. Well, let's move on to the next section and I'll explain that to you. So now let's actually get to the Python part of this. This was just like kind of a surface level GraphQL explanation that we went through. So there's increasing diversity in the GraphQL Python ecosystem. So there's both code first and schema first approaches, like I mentioned. Graphene is a code first implementation of GraphQL, and it's one of the most established ones. So that's what we'll be using today. There's also bindings for Django and pretty much any other popular framework like SQL Alchemy you could think of. So we'll be using Graphene Django bindings as well. So kind of like to go to that question about like what happens with the server side of things, like how does this query get resolved? So it kind of starts from the URL route. So if anyone's familiar with Django, you know we have this urls.py. We define all of the routes that our application is going to serve. In this case, we just have one endpoint for processing GET or POST requests, and it's just GraphQL. That's the endpoint that we were using for GraphiQL. Graphene provides this GraphQL view that we can use as the view for that route. We pass it the schema, which we'll define in code, and we tell it that we want GraphiQL enabled. But you can disable it for production if you don't want people poking at your API. So the schema is defined through Graphene. So we have our schema here, which we passed into our view. We define like a root query object, Graphene object type. And on that root query, we define fields. So we have stories, which is a list of story type. And we define that custom story type up here. So this is all like analogous to the SDL on the left that we talked about earlier. So we have our fields, ID, title, and subtitle. We have an author name, which is camel cased by automatic with Graphene, so we don't have to worry about maintaining consistency with Python's standards and the web standards of camel casing. We'd also define some arguments as well. So this is our display argument, where we have an argument, display, takes the enum with the default value. So each field in our schema has a resolver function. So a resolver is a simple function that returns the data for a particular field, which will then be passed through to the next type in a graph. So in this case, we have a field author name that is provided data from the function resolve author name. So here's our field author name and the function, our resolver, resolve author name. So the value object that we're resolving is always the first argument of that resolver function. So here we have root as the first argument, and it's a model object. It's our story model. And that's the same for all of these things in the story type Graphene object. So the root is the story model for resolve subtitle, and it's the story model for resolve author name. Graphene allows us to have implicit resolvers if the field name matches the attribute of the root value object. So in this case, the field is called subtitle, and the attribute on our object that we're resolving is also subtitle. So we don't need to write that. Query context info is always the second argument. We'll get into that a little bit later. You don't really need to worry about it until you have some more advanced use cases. Any further arguments that are passed into this function, like display for resolve author name, are from our GraphQL arguments from the field passed as keywords. So any arguments on the author name will be passed as keyword arguments to resolve author name. So in summary, like resolver functions help us answer queries. So let's kind of trace through a query and see how those resolvers are connected together. So queries are first parsed and validated against our schema. So all these fields need to be in our schema. The resolver functions cascade data from the root query to individual fields. So we'll start from resolve stories. We'll get all those objects, all those story objects, And then on each of those objects, we'll resolve the author name and all the other fields that we want from that. So finally, we get that value, that string value for author name. So kind of like more diagrammatically, like following the flow of that data through. We start from the root query. Initially, our root is none. Then we resolve the stories, that story field. Then our root value is all those stories, which is then passed into each of the resolvers for story type. So we'll resolve the author name, the title, the ID for the first story, and the same thing for the second story, the author name, title, and ID.
So if there was a default implementation, you don't ever resolve for a given field? So if you just have story type and then you just put pass, does it have like default resolvers for all the two fields?
Yeah, if the attribute on the object is the same as the field name, then it'll just do a default resolver. Cool. All right, so let's do another exercise. So this time we'll be making a modification to the schema. We'll add two fields, description and published year. So ensure you're on the branch chapter 2. If you open up API query story.py, there'll be further instructions on how to make changes to the schema. And you can verify your changes through prepared tests and running sample queries in API queries.graphql. Sure, let's take a look. Okay. How's everybody doing? Any questions? Green build.
Returning the year as a string? Come on, man.
Yeah, it's a little goofy to put the year as a string, but trying to write a resolver. All right. So yeah, let's take a look at a solution for this guy. So our problem was to add description and published year fields to our schema. So the amount of code we have to actually add to this is pretty small, just to get the schema going. To add the field to the schema, we can just add description as a graphene string and published year as a graphene string as well. It's going to automatically camel case, so we can stick with Python conventions and use published year. A feature that I haven't really gone in here, but we can actually add description string over here. And this will actually go into our GraphQL documentation. And then for the resolver function, so since published year doesn't match with the story model field, which is published date, we need to write a resolver function. So basically we pass through, we have the root as our first argument, which is a story model, and we pull off the published year, published date, and then take the year part of that and return it as a string. If we don't return it as a string, Graphene will coerce that value into a string, so it's not a big deal. But yeah, let's just take a couple minutes. If anybody has any questions, I'd be happy to answer them. Yep.
Based on these examples of these, it looks like this could become pretty inefficient. Should be model cases, pretty big, and you're resolving down, at least the Django. Any tricks there?
So the question was about like performance and like concerns about like this quickly becoming inefficient, because I'm sure you're experienced with Django. You've spotted the n+1 query right here. So yeah, we'll address n+1 queries in a little bit. But yeah, if you don't address that, then it can get out of hand pretty quickly. So in this code base, we're using Django ORM. So the question was, where is the integration point with a backend data store? And let's just take a quick look at that. So basically, we have these models that are defined here for our Django ORM. So all this is already set up with the fixture data. So here's our story model. And it has all these fields and relations defined on it. And if you haven't used Django before, it has very nice migration capability to like manage the database changes. But that concern is kind of like separate from the GraphQL part. So, if you want to dig into that, feel free to look at the references that were provided for, this tutorial. Yep.
So you mentioned it as code first, where you define the Django code and the schema comes later. I noticed that you do it as a schema file. Does that need to be updated every time, or can it be generated?
The schema.py.
There's a queries.graphql and mutations.graphql.
Oh, yeah. So this file is just for your reference. Normally, you don't need to include the queries.graphql in your repo. Yeah, in the back. This bigger. Okay, it's not global. I'll keep that in mind. This is good though, right? A little bigger? Yeah, maybe I should.
Move to one up here if somebody's really having a hard time.
Yeah, there are a couple seats up here, so if you're having trouble. All right. All right, so let's move on to the next chapter. So, a phrase you'll hear pretty often when you start digging into GraphQL is this phrase relay compliance or relay standards compliance. And it can be a little bit confusing about like what exactly this is and why you might want it. So relay compliance is a set of standards created by Facebook that are required by their relay client library that's used in JavaScript. So it's not required by other popular client libraries used in JavaScript like Apollo. So you're not required to implement these standards. But the standard does include some useful patterns, so it's good to understand what they mean and how they're used, so that you can make an informed trade-off about whether you want to adopt relay compliance for your API. The GitHub API that we were looking at before is relay compliant, so they have that flexibility to, let people use either relay or Apollo as a client. So what does it actually mean when an API is relay compliant? So that basically means that we provide a mechanism for refetching the object, a standard way to page through connections of a list of data, and a structure around mutations to make them more predictable. We'll dig into each of these requirements and how we can pretty easily satisfy them using Graphene. So the first requirement from Relay is a mechanism for refetching an object. So you may have noticed that our simple API right now only has the ability to fetch a list of stories. So as our list of stories grows, as we get more data in our database, obviously we won't be able to send all of the stories to the client. If we have 1 million stories, we need a way to page through those results. Sorry, skipping ahead. Sorry, so we'll get to connections in a little bit, but for fetching a single object, going the other way, if we just want one story, a particular story, what's a good pattern? We could add a single story field on the root query and pass the ID to that, or we could follow relay standard. So relay requires a node field and interface at the root query that allows us to fetch any object that implements that interface. So let's dig into that a little bit more. So what exactly is a node interface? So an interface in GraphQL defines a set of fields that is shared across types implementing that interface. So in this case, the node interface just provides a single field to the type that implements it, an ID. In Graphene, we just need to use this meta class pattern, like an inner class inside of our Graphene object that has an attribute that specifies the interfaces that we're going to be implementing. So it's pretty similar to a pattern that's used by Django and other popular Python frameworks, so you may have seen it before. So when we have an interface that we're resolving, we need to know which type this particular object is that we're resolving. So if a node can be either a story or an author or a passage or any number of things, we need to know which of those things it is so we can pull off the fields from that. We can apply our GraphQL schema to it. So in Graphene, we write this function, isTypeOf. So that basically helps us determine if the object can be resolved with this type. So we have is type of, and in our case, we return a Boolean if it's an instance of the story model from our Django ORM. If it's a story model, then we can resolve it using the resolvers that we specified in story type. Like those fields apply to it. So when we want to query that node field, this is what a query might look like. We can pass in variables into our static query. So here we have some variables that we might put in our query editor down here. And we pass them through as these references, this ID reference, into the value here for the node ID. We can alias a field to something more meaningful. So node is pretty generic sounding, so we can rename that in our results to story, because that's what we're expecting back. We can also have an inline fragment, which only fetches these fields, the title and description, if the type of the node matches that story type. So that's when that is type of comes in handy. The node ID value is meant to be human readable and globally unique. So Graphene base64 encodes these ID values under the hood that encodes to the story type and the ID, so the GraphQL type and the ID. And it's going to be using that ID under the hood to resolve which particular type should be used. So the node field returns any type that implements the node interface, matching the providing ID. So we don't really need to write much code for this. Graphene provides a pretty good interface out of the box. The one thing that we do need to write, however, is a method that tells Graphene how to get that particular node when it matches on it. So it'll match on that name of the type, the story type, and then it'll pass in that ID value into the getNode class method. Oops. So basically, we'll get the ID through here, and then we'll pass that to our ORM to get the story that we want for that primary key. All right, so let's just take a couple minutes to try out a query on this node field. So this is a little more complicated query. We're using the variables. So when you open up this queries.graphql file under chapter 3, you'll have some variables here. Just paste those into the variable editor in your GraphiQL. So let's see. Chapter 3. So you can see here, I forgot to paste those variables in there, so I'll just take those variables. Try to make this bigger for people in the back. And I'll paste them right in here. So we can get a list of all of the different IDs, copy it from there, and get a different story back. Just maybe one more minute. Any questions? In the back? Sorry, I can't hear you too well. Is there a way to use IDs without base64 encoding? Yeah, so if you don't use Graphene's implementation of Node, then it won't use base64 encoding. Not use the Node interface, not use relay. There are reasons to do base64 encoding that I'll get into in a little bit later. So there's some, it is a little bit weird, but like there are some good arguments for using it. Yeah.
I'm missing the display argument
Mm-hmm.
in the resolver. And does this look right? Are these the resolver for the public here?
You should get rid of display right there.
Oh, okay. Does it need that?
It doesn't need that, yeah.
Okay.
That should be good. Okay. Yep, one more question.
If you're using, like, you define node on your query, you have to define get node for every single implementation after that.
Okay, so the question was, if you're using Node, do you have to write get Node for each object that you have? So if you're using something like Django, you might be able to write like a generic implementation of get Node. I think with the SQL Alchemy bindings, there is a default implementation. But with like user access and things like that, there's often like specific concerns that you might want to handle for each model individually. But yeah, you would need a get Node for each one. Okay. All right, so the next bit about relay compliance is the connection. So, like I mentioned before, we have a array of stories here. And as that list grows, we need a way to page through the connection. Since we don't want to send 1 million records back to the client, we need them to tell us how much they want. So we need pagination. So relay connection provides a pretty easy to implement solution for pagination using Graphene. So what does that look like in practice? So this is an example of a query for doing pagination forward through a list of results using the cursor API. So first, we have this first parameter here, which is basically our page size, saying that we want 10 records. We have a variable here, the after cursor, and basically that's saying we want all of the records after this cursor, so the first 10 records after that particular bookmark. we have a page info object here, which tells us what the last cursor or bookmark is for this particular set of data, and a Boolean that tells us if we have the next page of data. We also have edge and node for each record, which is like a graph-like metaphor. So basically the edge, each edge has a cursor, which is like a bookmark that you can use for pagination, and the node, which is the actual data that we're looking for. So everything inside of node is our story record. So really connections use a cursor-based pagination API. You might compare that with a limit and offset-based API, where you would tell it you want 10 records offset from 100 from the first record. The cursor API is opaque to the client. It's again like base64 encoded, and it contains all the information needed to paginate the results. So you can have a very specific implementation of the cursor that is encoded for maybe doing a more complicated query than just limit and offset, which can have some performance implications if you have a large set of data. So Graphene basically uses limit and offset under the hood for the cursor, even though we use that cursor API. The connection arguments first and last determine the limit, and the cursor is base64 encoded again. So the cursor itself determines the offset. So here we have like an array connection, 0, so that's the pagination style and the offset. So you can write a custom cursor if you need to, but that's out of the scope of this tutorial. So the connection API for cursor-based pagination provides us with a lot of things out of the box. So for us, we just need to write a very little amount of code. So we write graphene.connection field, and that gives us all of our pagination parameters, first, after, last, and before. We have to write a story connection, which inherits from graphene connection, and that gives us all of our page info and edges. We give it a meta with the node type, and that will actually resolve all the nodes for each record. So just from 3 lines of code we have, or 4 lines of code, we have like a pretty decent pagination implementation right out of the box. We can use these arguments first and after with the end cursor, and has next page for paging forward, and these arguments for paging backwards. So moving from list to connection, like we just did, that's a breaking change for our API consumers. And in fact, like adding pagination on any list is really going to be a breaking change. So we want to consider carefully which fields require pagination up front. And using connection instead of list doesn't require that much effort with Graphene, so something to consider. All right, so again, let's try out some new queries. So check out chapter 3b this time. And your API queries GraphQL should have some example queries and more specific instructions about how you can page through these. Let me come over. Yeah, one thing to remember when working with variables in your query, like we have here, so we have this variable after cursor. If we try to run that without specifying the value, and it's not nullable, so in this case, if we try to run this query here, that works because we have our variable specified here. But if we get rid of that, we're going to have a problem because that's a required argument. So we just put the value for story ID down here, and then it'll work fine. For this query, we haven't specified that the after cursor is a required parameter, so we can run it fine without specifying that. If we give it a little bang right there, that'll become required, and it will complain. But really, it's fine if our after cursor is null in this case. So if I want to page to a random part of this data set, or if I want to page to the next page, I can take this end cursor, use it over here, and then run it again. So right now I have these 3 stories. If we run it again, we get some other stories. I can also like just pick a random cursor. I can pick this one. And now this next page will start with this result here, Raven Tower. Cool. All right, so let's keep moving on to the last piece of this about GraphQL. Did you have a question? Okay. Oh, okay, back there. Yes, you can definitely, so the question was, is it possible to have a lookup not just by ID, but by a name? So GraphQL is very flexible, so you can actually specify any arguments on any field. So you can just arbitrarily specify argument on a field, and then that can be used in your resolver to get the data that you want. This is just one standard way to do it. Another question? So the question is, do you have to implement Node to be able to like look up by any other thing? No, like if you're implementing by Node, this is just an interface that you can use to fetch any arbitrary record. It's totally possible to use like a slug or something like that to look up a record as well, but you're basically implementing a custom interface at that point. Relay interface is standard for that Relay client library. So the last bit here is structure around mutations to make them more predictable. So from our perspective, this is actually pretty straightforward. Graphene does most of the heavy lifting with this again. So there's no big changes to the structure or behavior of mutations to comply with this part of the specification. We still receive some arguments and an input. We still change data in our mutation function, and then we send a response. The big change that Relay needs is that it wants to have a standard way to receive the input or send the input in, and it also wants the input and the payload to send back this client mutation ID without changing it. So in practice, that'll look something like this. Like this mutation is relay compliant. It has this client mutation ID, which is just whatever we want it to be as a client. So I might call it like mutation 1. And when we send back the data, we just say, hey, this is the result for the mutation that you asked for, this mutation 1. And internally, that's used by Relay for tracking purposes, but not really important for most clients. So in Graphene, the code is pretty simple. We just inherit from client mutation ID in Graphene, and we get this for free. So client mutation field is automatically added and sent back in the payload. We specify the input that's passed into the mutation in this inner class, the input inner class, with some fields that we want to send to the mutation. So like title, subtitle, and description will be arguments that we can send to create a new story. And that will be sent to the keyword argument here, the input data. So to sum up, Relay compliance is just a standard with some good GraphQL practices. It's pretty easy to implement with Graphene. And you might want to consider carefully if you don't want to adhere, because adding connection or client mutation ID later will be breaking changes for your API. So let's just take a couple minutes. And yeah, if anyone has any questions, I'm happy to answer them.
I had just, as far as, I work with a lot of APIs on network devices and firewalls. Do you see guys like those evolving to support this kind of thing? But all of them have like a REST API.
Mm-hmm.
They would have to change, they would have to add a GraphQL server into their code.
Wait, so the use case is like you have some third-party APIs?
Yeah, I use a lot of third-party APIs.
Yeah. So there are a lot of first-party, or there are a lot of people who are building out third-party GraphQL APIs, like GitHub, for example. But there are also people who are doing like API gateways for third-party APIs. So like I mentioned in the beginning, like you can kind of wrap a third-party API in your GraphQL API endpoint and then receive the result back. So yeah, even with like microservices, like in internal services, people use it as a gateway, consume all of the data, and then send it back. Hey.
So I unfortunately am going to have to bow out at noon, and I just wanted to apologize in advance.
Oh, no worries.
I'm really enjoying the class. So
Cool. Oh,
sorry
thank you.
for being rude at the end of the class. I have a meeting that I have to go to, but
No
thank you
worries.
again.
Well, the material's all there, so you can feel free to go through it or email me with any questions.
Really appreciate that. Thank
Yeah,
you.
no problem. All right, so should go another like 30 seconds and then we'll get started. All right, let's get back to it. Okay, so let's talk about schema evolution versus versioning. So making changes to public interfaces can be hard. With an API, there can be multiple consumers, and your single page front-end application or an Android or iOS app. The information that tells you if a change is safe to be made is spread pretty thin across all those different places. And if your API is public, then there are even more considerations that need to be taken in order to avoid breaking any consumers that you may have. But there's some general rules of thumb that we can follow to help us evolve the schema without breaking changes. And GraphQL provides some constraints that make adhering to those rules of thumb a bit easier. So what does it look like to evolve without having breaking changes? So given some query with a selection of fields, arguments, and variables, if it returns the same types to the client before and after the change, then we can say that that's not a breaking change. So types help us make that promise more easily. The schema is a contract that isolates the client from the implementation on the server, so we're free to refactor how that data is fetched and provided to the consumer, as long as the types don't change themselves. So there are ways to do this with REST and any other API standard, like RPC or what have you. But particularly having a schema is very helpful with implementing this contract. Additionally, like base64 encoding tokens, like ID and the pagination cursor, also encourage client safety. So a change to the implementation on the server shouldn't affect clients like we were saying before. By base64 encoding our tokens like ID and pagination cursor, we're discouraging clients from parsing and interpreting data that's used by the server internally. So basically, if they start messing with our tokens, then it's their own problem if they get burned. But the interface of how these tokens are used won't change as we evolve the internal implementation. So if we decide to go away from like a connection that's paginated through offset, like the internal implementation of Graphene does, and do a more efficient database-based cursor, we can do that without worrying about breaking all of our consumers. They don't need to change the API in order to benefit from the better performance of our internal implementation. So if we add a new field, in GraphQL we have confidence that when we add that new field, it's not going to have an impact on existing queries that use that type that we've added the field to. And that's because new data is only exposed to the client when it's used in a query. So until we add that into the world, it can't be used. So we know it's not going to be sent to the data. Even with REST, we can make that kind of change safe as long as we maintain the schema for the other fields. But if the new field is expensive to compute, we don't really have any guarantees about performance impact to the clients with REST. With GraphQL, we know that clients are not going to be impacted by adding an expensive to compute feature to our API because they'll only fetch that if they need it. So if we add a new argument to one of our fields, as long as it's optional or has a default value, we know we can add it fine. Same as evolving like an API in a method or any other object. Even on clients for GraphQL with statically typed systems like Android or iOS, they're typically only impacted by changes that affect the return type of queries, because that's really what they're typing in the API itself. It may break RPC-style generated code from specific libraries, but that's not common with GraphQL. It's more common with like gRPC and things like that. So in general, the same principles for evolving GraphQL APIs apply to REST APIs and any other public interface. Google's API design guide really codifies this very well. It's a reference that I would encourage you guys to check out if this is something that you're interested in. The guide is written with REST and gRPC in mind, but the concepts are broadly applicable even in GraphQL, especially given that gRPC, similar to GraphQL, has a schema for all of the responses that are sent. So in addition to the schema, the GraphQL community has developed useful tooling and techniques to safely evolve APIs. So for clients with known queries, like if it's a client that we control, our API, so if it's a client that we control, like our web front end or a mobile client, we can do contract testing by checking the types of static queries against the static schema definition. We can also do like resolver level middleware to track API usage from live production queries on a per field basis. This is a kind of tool that Apollo server provides and is broadly used as a technique in the GraphQL community. With REST, it's a little more difficult to get per field level information about what is being consumed and know how things can be changed. So inevitably, we're going to need to make a breaking change to our API. GraphQL's built-in deprecation reason can be used to communicate changes to consumers. GitHub does a really great job of this. We can take a look at that in a little bit. They have all of the changes that are going to be breaking to their API scheduled months out without ever having to version their API. Introspection can also like warn fields about using, introspection can also warn clients about using fields that are marked for deprecation. So that can be helpful as well. In REST, versioning is often the default option, so we might add another endpoint that versions a particular schema of our API. In GraphQL, it's not the first choice, but it can still be done. It's still an option as a useful escape hatch if we really need to do some vicious refactoring. Shopify, which is a pretty big proponent of GraphQL, has recently added versioning to their APIs because they have a special use case where they're providing a platform for people to build consumer products, so they want to have a stable API. Cool. So let's consider adding a new record related to the story author to our API. So in REST, we might add a separate endpoint, v1 authors. We might add links to related records as URL, which may lead to n+1 on the client side. Or we might embed the author directly into the story request, which might lead to overfetching for some clients. Do we need to bump the new version for stories endpoint? Will that have an impact to clients? It's a question. With GraphQL, adding fields is a safe change. We don't need to worry about it. So here we have, we're leveraging connection and node from our previous talk. So we have an author connection that we're adding to the root query, and our author type is implementing node, so we can fetch a single one. In terms of graphing, like how should we structure our project as we grow? As with any other project, we want to have like small modules that keep like things together. In this case, we've organized the project with a package for query and mutation separately, and a separate module file for each of the different types. So trying to keep the module files pretty short and focused. You can also invert this and have author as your package and query and mutation as your module, but either approach works fine. For our base query, we combine these using multiple inheritance. So basically we have some root query here, and we inherit from story query and author query. And same thing for the mutation. By inheriting from all of those, we get all of the fields. There's a risk that you could have the same field, but that'll break your schema anyway. So yeah, let's try to do a meatier exercise now. So let's try to evolve our schema, write some more graphene code, and add this authors type. So the connection and the author type. So you want to be on chapter 4 branch, pair up with somebody, open up API query author.py, and follow the instructions there to implement changes to the schema. There's also some sample queries over here in API queries.graphql. So I'll pull that up here and we can kind of go through it. So we're running a little bit ahead in this section, but let's check in maybe 10 minutes and see where everyone is. If you have any questions, feel free to raise your hand, try to help out. How's everybody doing so far? Need some more time? Yeah. Cool. Let's take like 4 more minutes and then. Actually, let's take another 7 minutes, and we'll count that as our break too.
The login for this, is it going to normal Django log engine, or where's the logging?
Yeah, it's just.
Curious, because I'm not seeing, okay, I'm seeing that. I am seeing that, never mind. I wasn't seeing this before, now I am. I have it running up on DigitalOcean, and I'm hitting that for executors. Just because I didn't want to deal with the Windows.
Oh, gotcha.
Yeah, root is already author. So there's that. Yeah. And then the last thing is if you go back to stories, and look at author name. The author. You have this display thing, and you need to, yeah, it's literally on that one. Cool, that's what happens.
Okay, gotcha. Thanks.
So in your author line, you need the author displayed. Yeah. You're also over indenting. Okay, so here's something. You want these to be underscored, and then GraphiQL will automatically say square. Undent. And then get rid of this. In string. Yep. You need to,
The args, args equals.
yeah, you have our example, you're missing a closely round. There's that.
What's the,
Hmm?
what were you using with that input?
Because, so when I ran the tests, what was happening was it wanted this 19, either first or last. Display options.
First and last.
Yeah, but if you, so it can't be first and last, but it can also be last and first. And then on the author line, there is a full name that would choose how to see their pages. So it's different models. So you file. So yeah, in here, you need to change that model options. And because the root is already authored, you don't pass through that, because that's essentially like important there. So kill off. It's just root dot root.
Yeah, we're by putting this.
Yep.
So, I'll change it to there's three methods, right? And the four fields with the args.
Good. You're good.
So can I see which methods on the first one?
Mine's not.
Okay.
Hey. Oh, you were asking a question? Oh, for me?
Nothing changes, it's just the same thing.
Yeah, it's really copy paste.
Okay, so
You have meta classes.
Oh, the implement interfaces.
oh, I don't have that.
Yeah.
dots are passing the absence values. So if you look at this.
Oh, wait, it just.
Okay, so let's take a look at the next part. I know a lot of people are still working on this one, but try to get through all the material. So, oops. Okay, let's take a look at a solution for this guy. So I will check it. Check it to 4B. All right, so just really quickly, let's take a look at the solution for this guy. So to implement the author type here, we're going to use this meta class to set our interface as node. That's going to give us ID for free. We can specify the first name, last name, and Twitter account as a string, graphene field. We can also specify full name as a string field, and we have to pass through that same stuff that was already set for this field in the story py. So we'll set the argument, display name enum, and all that stuff. For the resolvers, for full name, we need root info and this display argument, which comes from right here. And we'll call the full name method with the display argument. For isTypeOf, we just check if the root that is being resolved is an instance of the author model. And for getNode, we just try to use the Django ORM to get the author object using this key that comes from our base64 decoded ID. For connection, we just specify the node type as the author type. And we add authors and node as a connection field, and we resolve authors using Django. Cool. So let's move on to the next thing. So we can also add fields that connect two different types together. So the author and the story are related. Each story has one author. So we have the author defined on the story type as a field, and the author also has a list of stories for each of them. And we can paginate across that list of stories because there are some authors out there who are quite prolific. So adding this kind of connection makes it a more flexible API. We can navigate from any single node to any connected type, which is very flexible for our clients. In Graphene, we use field and connection in Graphene we use field and connection field with Python module string. So we can use this graphene.field for like API query module type, and connection field API query module connection type. This is, we can also pass in the thing itself, like as we have over here. So we have a connection field with the author connection that's defined right here. But this is just a little trick to avoid having like a circular import in Python. So we can also deprecate fields that are no longer required. So author name is no longer required on our field, or on our story type, because we have a more rich way to describe that relationship. The user can just fetch the author full name instead. So we can give it, a deprecation reason. Similar to how we can specify description on any graphene schema object, any field, we can also provide a deprecation reason, keyword argument with the reason text, and that will become available in our graphical documentation explorer. So if we go over here, in our documentation explorer, we can look and see, if a field is deprecated, it will show up over here. So as a further evolution of the schema, let's try to add this connection between author and stories and story and author, and specify a deprecation reason for author full name. So this will require the branch chapter 4b. That will have the solution of the previous exercise there as well. And you can open up author.py and story.py and implement the changes to the schema. There's also some new sample queries in queries.graphql. How's everybody doing? Yeah. Yep. All right, so let's look at an implementation for this here. Okay, so in this exercise, we're trying to add a connection between author and stories, and story and author over here. So let's take a look at author first. So to implement the connection from author to stories, we can add a field to our schema It's a stories field, and it is a graphing connection field using this module path. So API story, API query story connection. And then we write a resolver for that, just using the Django ORM. So our root is our author model, and then from the author model we can get stories and all records. So all related stories to the author.
How does that filter for a given author?
This is a Django model, the author, and this has a one-to-many relation. That's called stories. So in model, there's this related name stories on author. And then if we look at story, so on story, we add the author field, which is just a graphing field pointing to this author type. And I wrote a resolver here, but this is actually something that we could have being an implicit resolver, since the name of the field author matches the name of this attribute, which is a many-to-one relation on the story. Okay. So to sum up things we were talking about before, GraphQL gives us tools and techniques that help us prefer one unified evolving API over many versioned endpoints. As long as the schema used by the existing queries doesn't change, or used by existing queries doesn't change, our API can grow. So we can always add more fields to it. We can also schedule breaking change through deprecations to allow for more drastic changes. These same techniques can be applied to Rust or any other public interface with some discipline. So over time, our API can grow into something surprising, something very different than we expected. So beyond supporting stories and authors, we might represent a choose-your-own style of story with passages and choices with a much more complicated data model. So how do we scale our API's performance as it grows to be more complex? Performance tuning with GraphQL can be a little more challenging. It's not generally possible to do HTTP level request casting because we only have one endpoint, GraphQL. And the things it returns can vary pretty wildly. The n+1 problem becomes more serious as our API grows with more connections too, as we're making more hops between related objects. So what is an n+1 problem? Like people who are familiar with ORMs might have heard that term before. This kind of tries to diagrammatically explain what an n+1 problem is in GraphQL. So this is a pretty simple query in GraphQL. We just have, we're just fetching all of the titles and authors for our stories, just the first three. So in this case, first we get all of our stories from the root query, and we get them all in one go. So this dot represents one query that we hit to our database. Then we have to resolve the author for the first story, and that's another query for our database. Then we have to resolve the query, or the second author, and that's another hit against our database. And same thing for the third. And if we had a fourth, a fifth, a sixth, a seventh, it goes on and on. So you can see that this pretty quickly adds up to be a problem, especially if we have a more nested query. Like this is a choose your own adventure query where we have stories with passages and choices and two passages, just describing the entire graph of all possibilities in a choose your own adventure. And so we'd have one query for stories, another for the first story's author, another query for the first story's passages, another for the first passage's choices, the 2 passages for the choice, back to the second passage, and so on and so forth. It's just completely out of control. But there is a solution to this. But just if you want to give it a shot, you can check out the chapter 5 branch and maybe just like spend a minute looking at the logs for n+1 queries. So we have some sample queries. I'll do it up here so we can follow along together. So I'll check out chapter 5. Go over here. So we have our query here. If I go to my logs, I'll run that query, and we can see that this is what hit our database. We have one query for all the stories, and then one query for each of the authors of the stories. When we do something a little bit more complicated, oops. Oh, I changed my variables. Variables, come. There we go. That's a lot more beefy of a query. There's a lot of extra things that are happening there. So how do we fix this up? So we might try to aggressively select related data in our queries. So Django has some nice facilities to let us do that. We can select related objects, select related authors on the story when we're getting that, and maybe select related 2 choices and 2 passages when we're getting the passages. And that can help us have less queries to our database, but now we're overfetching in the case that we're asking for less data. So we might not want to do that. Using DataLoader is the Facebook preferred approach. So this is provided in the GraphQL Python ecosystem. DataLoader will batch requests to the database across nodes. And it will also do caching at the request level for all the results that we get back from our database. So what does that look like in practice? So this is a data loader right here to load passages from a story. We want the data loader to only live in the context of the request. So this loader is set up on the request, on the request context here, using that info object that we were talking about earlier. We have passages from story loader on that. We call a load function using a hashable key. So in this case, we're using the ID from the model to get the related passages. DataLoader is going to batch those keys across all of the requests that we had. And then it's going to load the values in bulk. So it's going to get all the passages for those story IDs using the Django ORM. Then we're going to need to return the keys, or return the values in the order of the input keys. So that's what this little flippy bit over here does. It basically just takes these results, the passages, and returns them in the order of these story IDs. So then DataLoader will take care of ensuring that everybody who needs a particular story ID gets what they asked for. So we take a look at our simple query performance example again. We again have one query for, or one hit against our database for all the stories. Then we'll call the load method for each of the author IDs. So for the first author, second, third author, fourth, fifth, and sixth. And we haven't hit the database yet for those authors. Now, DataLoader is going to resolve that all at once by calling batch load function and loading all the authors in bulk. If there are duplicate authors, we'll only fetch them once, even when they're used in multiple stories. So that's a pretty huge change, and we'll get a very much larger boost in performance to our queries. So that same ginormous query we had before, we'll get all the stories in one query. We'll get all of the authors in one query and cache them as well if there are multiple authors that are used that are the same. We'll get all the passages in one query, batched across the stories. We'll get all the choices in one query, batched across the passages. And we'll also get all the two passages cached because we've already fetched them for the stories. So we can try that ourselves on the chapter 5b branch. So now we can see that there's going to be some batched queries. So I'll just check that out, and we can all follow along together. Okay. So for our simple case, we run that, and instead of having around like 11 or 12 queries we had before, we only have 2. We have one to get the stories and one to get the authors. And if we run our monster query, we have a lot of IDs that are batched, but we only have 5 different queries that are actually fired to the database. One for each of the objects that we're resolving. Yeah, so I want to take a little break right now. If you guys have any questions, I'm happy to answer them about this too.
Is there a way to specify using eager loading within the ORM to sort of do the joining at the query time?
It's a bit complex. I've seen some libraries in the JavaScript ecosystem to do that kind of eager loading. To basically that you have to parse out the entire query. So you have like abstract syntax tree of all of the fields that you need in your query. So you'd have, an AST that represents all these things. And then you have to decide from that AST what joins you need to do for your data models.
SQL Alchemy has eager loading built in, right? So theoretically, if I'm already going to the trouble of writing a batch loader for this thing, I could just specify to use eager loading on some of the objects and not have to go through the hoops, but I'm not sure how that works for this.
Yeah, I'm not sure about SQL Alchemy. I've worked with Django mainly. There are some bindings for graphene with SQL Alchemy.
Yeah, I was looking at that. The simple case is really nice. And like everything else is like, it's not simple. But it's nice for the simple case.
Yeah. And I mean, data loaders are a little bit wonky, but like when you wrap your head around them, it's pretty easy to write one for, you can have a generic one-to-many loader, one-to-one loader, so on and so forth. Uh,
Still gathering the same data, so now Django is really doing more of the work, or exactly where are you shifting the load?
Sure, yeah. So the question was like, where are you shifting the load when you use a data loader? So the answer is that you basically need to add additional layer to your API. So can I open up some of the code so you can see what that looks like for the refactored API. So here, instead of like using Django to resolve the author, just with like, previously this was just root.author. So pretty simple. Now we have this additional layer that manages loading. So we do loaders author load with the author ID. So this will avoid doing another database query, and DataLoader will do the hard work of gathering together all of the IDs and batching them in one request.
So if you had a heavy use of this, you would create some data loader node, and that's where you're putting all of that.
Yeah, so for a heavy use case, yeah, you'd have like a data loader for each major connection between models in your library, and you would defer to that. All right, so we have one more section. So this section is about building a client web application. So GraphQL's full potential is really more realized with like a single page app with a rich client. It's kind of like peanut butter and jelly, like they're just better together. So you can use choose to use GraphQL client like Relay or Apollo to manage API concerns like asynchronous loading and error state, response parsing, normalization, caching. In this case, we're gonna look at Apollo pretty briefly. So as Apollo is a powerful framework that lets you focus on writing application code. So we don't need to worry about loading, sending requests to the API, handling error states, response normalization of all the data, and caching that data. So we can use Apollo with a number of things, like any JavaScript front-end framework like Vue or React or Angular. And there are a number of clients for iOS and Android. But we'll just be looking at the specific use case of using it with React. So this is all the code that you would need in order to run a query, which is a similar query to what we've seen before. We're just getting the stories, title, published year, and author name, and just displaying that out on the page. So we have our query here, and we pass that into a component for our React, our Apollo query object. Apollo is going to take a function that will give you these loading, error, and data. So the loading has this loaded true or false yet. Error is what kind of problems happened when it was loading or when it was resolving the data. And the data is just the stuff that you get back that you see in GraphiQL. So if we're loading, we can handle that by just returning a different state, maybe a loading spinner. If there's an error, we can send that out or report it to Sentry or some other logging service. And then we can just work with the data. So we can take our data, iterate over each of the stories, and put that onto the page pretty easily. The setup is pretty easy as well. It's just a couple of lines to get started. So we just specify an Apollo client with our URL. So in this case, it's the GraphQL URL that we've been using with GraphiQL. And we provide that client to a provider, Apollo provider, that will make it available for anything that needs it. So when we're building a client web application with Mutations, it's pretty similar. We follow the same pattern where we're defining our mutation in this query. So this is one that we've seen before to create a story. We provide that mutation to the mutation component that Apollo provides. This will give us a callback, a function that we can call with all the variables that we need to send. So the title, subtitle, description, published year, so on and so forth. And yeah, Apollo basically just handles the concerns for us. When data comes back, it's going to handle the response normalization. So if we have these list of stories coming back and an author for each of the stories, so we get back something that looks like this, where there is two stories and an author that's shared between them. Apollo is going to normalize that and store the author as one key in its cache. And it's going to store a different key for the story, the first story, and the second story that references the author key that we already have over here. And it'll also store a root query that has a reference to both the stories that we've resolved. So as we add more queries and mutations, if all objects have an ID that's consistent, using something like our global unique ID that we were talking about before, like we have an author ID between these two queries that's shared, a story ID query, that's shared between these, where we're updating a story title, then we know that the cache will be updated because it's going to match when it updates that key based on the ID. And the data is going to flow automatically to all the components in our application. So that's pretty powerful. We'll have consistency across all the application pretty easily. There's also some really good development tools that help us visualize what is going on in that cache and also show us like active queries and mutations that are there. Any questions on the React bits? Cool. I'll try to go into some of the edge cases here. So we might see some caching bugs as the page starts growing, as we have more queries. But there are some simple rules of thumb for designing mutations in order to keep our cache consistent on the client side. And when those rules of thumb don't work, then we have some nice escape hatches that we can follow. So when we're removing items from a list, like in this case, we're removing this story with author ID and story ID. And we return back the data that's been removed. We might not see the item properly removed on the page. So Apollo provides a mechanism for manually updating the cache. So we can write a function where we read from the cache and then write back the data without that story ID. That's like a little bit hard to reason about and test. So it's better to avoid it when you don't need to do it. We could also refetch any simple affected queries, so that's pretty simple. We just provide the name of the operation we want to refetch. But as the page grows, it can be hard to maintain a full list of queries that are impacted, and it can be expensive to refetch as well. If we design our mutation payload correctly, though, we can just refetch the membership of that list. So we can refetch the story IDs that belong to a particular author ID. And then the cache will be updated automatically. So it's useful if the number of stories on the author is small. If it's a larger list, then we might want to use some of our escape hatches. When we're adding to a list with a mutation, it's pretty similar. But if we follow this same pattern where we're just refetching the story membership on the author, we might have an error because we're missing fields. We're missing this description. And this component that uses the story for authors needs that description field. So fragments can help us ensure that we have consistency when we're refetching data across different parts of the application. So in this case, we define a fragment, all story fields, that has the fields that's used in our query on the left and the mutation on the right. So that ensures that the fields are correct and our membership has already been updated. So there's just one last little exercise. So we have a front end for the application. If you check out chapter 6 for the back end and front end applications, you can have them both running. And we can see that there's a caching bug. I'll show that to everybody. Cool. All right. So we have a React app here. We have a list of stories, just basically displaying title, year, and name of the author. And for the author, we have a button that will let us add a story. But it doesn't seem to do anything unless we refresh the page. Then those will come through. So what's happening here is we have a caching bug similar to what I was talking about before. But the solution is really pretty simple. We can just go into our Add Story button. And we can modify our mutation here. Since we've already designed our mutation that it'll respond with the author, we can add author. Refetch that author membership for the stories. And then when we refresh this, oops. Let's give that query a shot. Just going to add some value. Let's see. So we pass through these values. Let's see. And oops, that's what it was. Okay, so we have a corrected query over here. Just paste it in. Oops. And then it should work. So now it updates properly because we're refetching the membership. So if you want to play around with that for a couple minutes, then we can wrap up. All right, so just to wrap up, kind of evolution in a nutshell. GraphQL provides us some constraints to build a minimal evolving API. Our statically typed type schema and queries are a guide for what's safe to evolve over time. It allows you to focus on domain modeling, guides you towards that, and guides you towards a rich backend with a lean front end. Fields and arguments can really specifically describe the exact data requirements that are required by your clients. There are also like powerful client libraries that let you focus on writing code that matters. So yeah, that's it. Yeah, sure.
I just wonder, so like GraphQL is like, by the example, very obviously like super powerful when you're using the API for like a front end client. Like what, like say you wanted to be able to use an API like for a front end client like this, but also provide like kind of just the raw stuff so somebody could like curl against it.
Yeah.
Like how would that, like would it work with GraphQL? Would you recommend it to do that at all?
Yeah, yeah, you can totally still do that. So actually, so the question was like, can you still like curl against an API like this, or use it for other purposes besides a client like iOS or React or what have you? So we can actually see over here. Someone else was actually asking about this before. Like, so you can actually curl the API. Like if I look over here. It's kind of a nifty thing in Chrome DevTools where I can just copy this statement as a curl. And so I can actually just run that from the command line. And then the results come back just as a JSON. So pretty usable as any JSON, standard library or standard API can be used. Yeah. Let me try to enhance. So it's kind of a mess. This is not really a formatted curl command, but you have basically curl against our endpoint, our origin, and then the various things that we're sending across, which is probably a little bit easier to look at in Chrome if you're curious about the specific thing. But basically there's the query, and there's the variables we're sending across, and then the data comes through. So in over here in Chrome DevTools, it's a little easier to see. So you can see the payload has, which also is very small for you, I know. Enhance. So we have the operation name, which was stuff, very helpful operation name. We have the query that we sent across as a string. It has the other mutation as well. And we have our variables that are passed through as well. So it's all like JSON. Yep.
So when you define using graphene and schema within the language, is there an endpoint that tells you what the schema is, or tell clients what the schema available, kind of like with still
Yeah. So there's a thing called introspection with GraphQL. And that's like an underlying requirement for a GraphQL server that's defined in the specification, where there are certain things that the server needs to tell you about all the types in the response. So actually there are some additional fields which are filtered out here, because most of the time you don't need to use them. But I can do this over here for introspection. So I can see that the type name for this node is an author type. And actually, if I go to GraphQL Voyager, I think.
Can't you see most of what you want in the rightmost pane on that graphic?
Yes, you absolutely can actually. So you can also like poke around at it over here. And under the hood, how this is working is through introspection. So this GraphQL Voyager tool here actually gives me a query that I can use, which is pretty neat, so it might be worth showing you. So this is what the introspection query that these tools would use looks like. So a lot of nonsense in there. But if I run it, oops. Something weird happened. If I run it and I paste it in here, this will show me like a nice little graph of all the types I've defined. So that's like from that introspection data, it knows what all these relationships are. So under the hood, Apollo is using introspection, Relay is using introspection, this nifty Voyager tool is using introspection, and so is the graphical client we're using.
Yeah. Follow up, guys. Do you know any additional tools for building documentation of APIs on GraphQL? So like either docstring. I mean, so if you're building an API, obviously you want your, if it's just an internal team, you can share it among it. But if you're trying to share it among the general public, getting your GraphQL endpoint, you might not want to have to manually write the doc.
Yeah, absolutely. So you're talking about like providing, your question is about providing documentation to a client.
Well, the public or a specific client, whichever. But just whether there are tools that you know of for doing documentation of GraphQL API.
So basically like all the documentation is available through introspection. So anything that I put on over here, like if I open up story, if I put a description over here, oops, a lowercase description. that will become available in this over here. Oops. Yeah. And then any tools can use that. So I'm not aware of like anything that makes like a nice pretty documentation page. That's just like a reference. But I'm pretty sure that GitHub is doing something like that. If we go to like GitHub's v4 API, I'm pretty sure they're like exposing that. GraphQL docs? Cool. Yeah, there's just like so many neat tools. I haven't kept them on them all. Cool. Any other questions?
So have you found any friction with end users that now have to learn this GraphQL language to use APIs when they're used to very simple interfaces with REST?
So you're talking about for like public APIs? So like edits.
So some arguments that I hear are, you're taking all of your work off and putting it on us. Now we have to learn this. It's like, SQL Plus on a web page.
Right. Well, I mean, that's an interesting argument though, because like actually for the client, it's actually a lot more work if they want to get related objects across a graph of relationships, right? Like if I go to like Spotify's API and I want to get like the song and then get like, some related playlist and things like that, I have to write a client that's smart enough to join those relationships together, whereas GraphQL can do that for you.
Right, well, they would prefer us to make them an SDK or a client that encapsulates a lot of that.
So like writing a wrapper around the API. Yeah. So there are wrappers around GraphQL APIs. So like, again, using introspection and things like that. Like there are libraries from, I forget the name of them, but like GraphQL. They do kind of like a wrapper around their GraphQL APIs to do kind of like ORM-like things. Yeah. Well, I'll be available for any questions. I'll be all week. So.
Very quickly, about, obviously we kind of need code first, schema first versus code first.
Yeah, I can pull up an example of Ariadne's docs. Yeah, so basically you're writing a string that has some like definition. And then from that string, you have to write your resolver function, same idea. And there is something about like binding it together. You have to tell it how to attach the resolver to the schema. So same concept though, across like all of the ecosystem.